and welcome to the July 2022 Algolia live coding session. For those that haven't been to one of these before, this is a aspirationally monthly live streaming session where we bring in guests to talk about different integrations and ways of using Algolia. So glad to have you here. The topic this week or this month is continuous content indexing for search using Meroxa Turbine. And very glad to have DeVaris Brown here. He is the CEO and co-founder of Maroxa. DeVaris has a deep background in engineering and also in product. He's done product for Twitter and Zendesk and Heroku before founding his own company. For those who don't know me, my name is Chuck Meyer, and I am a senior developer advocate here at Algolia. So I host these from time to time, and you can find me out and about sort of talking about Algolia with the developer community. So if you don't know what Algolia is we provide a set of hosted APIs for building search and discovery experiences for your front end. And your mobile applications. So that could be anything from integrating with our SDKs through integrating with third-party products, which is kind of what we're going to be talking about today with Maroxa. So DeVaris, why don't you tell us a little bit about Maroxa?
Thanks, Chuck, for the setup. And thanks for having me. I'm excited to be here.
Glad to have you.
Yeah, Maroxa is a code first data platform that allows you to build data products using your existing developer workflows. So no drag and drop, none of that. Just regular old code, regular old, just plain old code. Right, like get back to basics. I feel like there's a lot of complexity that gets introduced by tools. So that's why we started the company, right? Is just to make sure that people don't get bogged down with infrastructure and they get time to value and time to creating value very fast. And so we are all in on this data app category, and really what we're saying is that it's a application that uses real time or near real time data and events to solve a particular problem. And so today, how we actually got started with this was we used Algolia on our docs, and essentially we were having to go and manually update the indexes for when things would hit the docs and all that type of stuff. And so essentially now what we've done is built a workflow around Git. And so once something gets committed to Git, we basically call this Algolia data app that essentially syncs up the indices, right, and does all of that for us in real time. So I'm going to be showing just a little bit of snippet of how we do that, just a kind of contrived example, but I mean it's pretty powerful. So
That's awesome. That's cool. And I know it's just the two of us today. So just because I'm a paranoid person, are my slides showing? Can we see the slides?
your
That's
slides are showing. We're all
that's
good.
great. And also, so we are missing our if you've been to these in the past, Julie Ribot, who is our wonderful host, typically helps with monitoring the chat and things like that. We don't have her today, so I'm going to ask if you do have any questions for DeVaris, if you can ask in the Q&A section. You can see that in your Zoom interface. So ask on the Q&A side, and I'll keep track of those, and we'll get those to DeVaris as we go. But I'm going to go ahead and stop sharing my slides now, and I'm going to let you get to coding.
All right. I'm ready. All right, let's do it real quick. Let's get it, baby.
I'm feeling confident for you,
I'm
DeVaris.
feeling confident too, man. So let's go ahead and share my screen. Yeah, we can get going. So, if you're an Algolia customer, you probably know what this looks like. And so really what we're going to be going over today is how to take data from your operational data storage. For to me, today is going to be Postgres, and I'm going to every time that we make a change in the Postgres database, it will get reflected inside of my Algolia index. And so this will be a data app that lives long term. It runs behind the scenes, and For the engineers out there in the audience, yeah, this is something that you can check in the Git, you can code review and all that type of stuff, but we handle all of the infrastructure underneath, right? And so this is essentially what the Maroxa dashboard looks like. We have a resource catalog. This is the one I'm going to be using today, which is my Postgres database that has logical replication, which means that anytime that a change is made in the Postgres database, we will be capturing those events via a mechanism called change data capture. And then, that will get reflected downstream into the Algolia index. So, yeah, nothing crazy to see here. I'm not doing any kind of like, kind of man in the box kind of thing, Wizard of Oz type stuff. Like this is all live. So, here we go. So the first thing I need to do is create a Turbine app. So Turbine is our code first SDK that allows you to create data apps. Essentially, you create this app, and then you deploy it to the Maroxa platform. Your code translates into infrastructure orchestration commands. So behind the scenes, we're running a distributed managed infrastructure that has all open source components. That's one thing that we're really, really big on, is standing on the shoulders of giants to make sure that, we can, handle, if you're like, yo, Maroxa is cool, but I need something else, like we can hand over the keys. Like that was one of the big things that I learned from Heroku, is that nobody really likes a black box, right? And so this is one of the things that we are priding ourselves on, making open source contributions and leveraging open source. So that way, people feel a little bit more comfortable about all the complexity that goes on behind the scenes. But let me just get this started. So what I'm going to do is just init an application. Just call it PG to Algolia. It's going to be in JavaScript. And we do it in 3 different languages. Today, Python, JavaScript, and Golang. But yeah, this is what I'm going to do. And so let me just cd in the PG to Algolia. And then one of the cool things that we do out of the gate is that we give you all the ability. Here, let me just show you what we got. Bunch of boilerplate. Let me move this over here. Bunch of boilerplate, but what it does is it gives you a 1 second. I live, All right, there we go. What it does is that it gives you a contrived example to run, so you can see the power of this. So what we're doing here is there's we're getting some information from a fixture, and then we are anonymizing this customer email. So you can actually just run this locally, all right, and see what the output is. The cool thing about this is that it, even though we have the customer email, which is user example, we've anonymized it here. You can see the code and all that type of stuff. But the cool thing is that there was no infrastructure for us to set up. All right, you can immediately see the output of your code without having to worry about, damn, I got to set up Kafka Connect, Zookeeper, Docker, Kubernetes, like all this stuff, and whatever it is that you're using to do transformation, whether it's Spark or Flink and all that type of stuff. Like we run a local buffer that allows you to simulate what a stream would look like using fixtures. And so one of the other cool things that we'll do, and we don't have time, that if you all want to take a look at, is that you can actually generate this fixtures file with one of our soon-to-be open-source products called Turbine, which goes out and inspects a database. It basically pulls in all of the schema and stuff for you, and then generates some sample records. And I think that that's something that's super cool. So we're really big on developer experience and making sure that end-to-end, whether it's ingest, transformation, and distribution, and all the orchestration, like, is done in a very, very, very prescriptive manner. So, all right. So that is kind of what happens there. Let's get to building this app. So first thing I got to do is make some changes. So let me show you Maroxa resources list. I need to go get my Postgres database here. So let me change this from source name to pg log and save that. And then inside of here, let me make sure that you all can see what I'm doing here. I just have a simple table. I'm going to show you what it looks like. It's orders, and then you can see it. And sorry. So basically, all I'm doing here is just grabbing all of the orders and things from here. Right. This is in AWS RDS instance, and essentially this is just the orders table. So basically, what I want to do is eventually I'm going to insert into this table, and it's going to get all this stuff. But for right now, all I want to do is just grab the orders, and this is going to help us when we do some local testing. So, all right, cool. So the next thing I need to do is let me install the Algolia search library. All right, and let's just verify in my package.json that we are there, cool in the gang. And right now, what I need to do is basically create an Algolia helper file. And what this will do is essentially go out it'll create an Algolia client. We'll set the client index, and then essentially we'll write some code that'll update the index with the streaming records that are coming in. And so let me go ahead and do that. And Algolia.js. Cool. Let me just clear this so you all can see that. All right. So first thing I need to do is let me just go ahead and stub out this stuff with some comments so I can write this as we go along. So I'm just going to require some dependencies here. And then what we'll do is create the Algolia client. And then we'll do set the client index. And then this will be the meat of it, which is basically here. I'm just going to update the index with records. And then I'm just going to export the Z module. All right. So really the only thing that I need to do here first is, let me go ahead and save it, is to require the Algolia search equals require. I promise I can spell Algolia search.
Maybe I think there's an extra S in the search there too. Algolia.
Oh yeah.
There you go.
Yeah, I was gonna call it. Thank you, man.
You got it. I've
That
got
was
your
gonna
back.
cause a bug at some point. You know how it goes, right? I'm like, damn, why isn't this thing working?
I got your
Or
back.
why am I getting these errors? But
Hey,
yeah,
just real quick while you're coding that. So could you think of this data application as almost like kind of like an event loop around your data?
basically, yeah. Yeah, you
Okay,
can. So every time a record gets processed, it'll hit this function, it'll hit this code, this app, and then it'll do that again and again and again for every record that gets passed through.
cool. Okay,
Yeah.
thanks.
So yeah, let's just go ahead and create this client, and then I'll do something fun here, and I'll tell you what it is. So node developers will basically be like, "Yo, where did my .env go?" And one of the cool things about what we do here, and I think it's Algolia app ID, and then process.env.algolia API key. I think that's it. So one of the cool things is that how we've created our client, what we end up doing is that we actually, if you have these local environment variables set, we basically at the point of reflection, like when we compile the app itself and we package it all up, we actually pull those values from your local machine and then we store them securely on our side. So you don't have to actually include .env. The reflection process is actually, when we go talk about the functions that runs, right, like which is going to be this, we basically pull that out so we can stitch together a DAG. So it's like input is Postgres, then you have your source is Postgres, and that flows into a function, which will be this like, insert update Algolia thing. And then it'll, that's what it'll get called down. So it updates the index. We don't actually have a destination. So, but like all of the wiring, um, this is the process that we can pull this out from your local machine, which is actually kind of cool.
That answers one of my questions because I was playing with this last night and I was like, where are these coming in from? Like, where am I supposed to put them? So now I understand. So if I set them
Yeah,
locally in my terminal, you'll pick them up
yeah,
and it'll get pushed along. That's cool. That's good to know.
yeah. If you do a print env, you'll see. Like I don't want to do that now, but
Mm,
basically like like we do all of this stuff for you. So it's like one less thing that you have to worry about, one less dependency, like all that type of stuff. So I think it's pretty cool.
very cool.
All right. So next thing I got to do is set the client index. So let me just go ahead and do that. Equals client dot init index process dot env dot algolia underscore index. Cool. And let's go ahead and make that. All right, now here's where the fun happens, right? So we basically need to create a function that is going to update our index with, sorry, it's going to be called update index. I promise I can type. And then what we're going to do is like, we're just going to pass in a record. So every time a record occurs, it's going to pass that in. And so, one of so basically what happens is that every time a record is inserted into the database, we're going to pull that out. And so even when we make the initial first connection with Maroxa, we go out and do snapshots and we pull all of the existing records in, and then we start processing from there. First thing I need to do is just get the payload, do a little bit of destructuring here. Sorry. And that's going to be the value of the record. Cool. And then basically I need to get the command. So in CDC, the payload actually has like 3 different sections in the schema, which you can see here, which is kind of like, before, after, like what does the record look like before? What does it look like afterwards? And then what was the operation? The operations can be like create, it's just CRUD, right? And so essentially these are the values that we need to pull out, so that way we know what to do with inside of the index. So let me just go ahead and set that before, after, and then operation. Cool. And this is going to be equal to the payload. This is all that we need. All right, here we go. So the first thing that we have to do is basically we want to account for, let's just get reads or creates and then updates. All right. All right, so what we want to do, we say if the operation is equal to read, or op is equal to create, or op, not that type of op, is equal to update. Then we'll do some stuff here. So I'm gonna log something out here just to make sure that we get the proper information. And so this is basically, I want to know what the actual operation is going to be. And this is and then basically I want to get the ID as well. All right, cool. I just need the ID, not the index. Cool. All right. And then we're going to set the object ID. ID to the after dot ID, and then index So essentially, what we're doing now is that like now we're just basically saving the payload after the after state to the index itself, given the ID. And so now I'm basically just going to kind of walk through the easy part of it is essentially if I do index save object.
Just out of curiosity, for the read operations,
Yeah.
why maybe I'm not following. Why would we do a an update on a read operation?
So basically, I think the R's reads, but essentially, what we're doing is, say the question one more time so I can get that.
So I understand. So like if there was an update or a create operation, right? So we've got a record changes. So you would want to push that out to your index as well.
Yeah.
If you pick up a read operation, is there a possibility that that might have changed in the data event loop?
No, it doesn't. But I think it's just one of those things that like is one of the idiosyncrasies and complexities
Hmm,
of the connection mechanism. And so if we don't account for that case, then the actual like program will fall over on his head. So
got it. Got it.
so I'm just making sure I cover all bases here.
Okay, that's cool. Makes sense. I just had to ask.
Yep, all good. All right. So so this is basically the meat of it, right? Like all I'm doing is like if I get one of these things, and this is gonna blow up anyway. Essentially, once I get one of these things, once the after ID, I'm looking that up and I'm basically saving it, right? I'm saving the object, but I got to make sure that I'm doing this in a asynchronous manner. So wonderful promises. Promises, promises, promises. Cool. So let me just make sure I resolve this after, and then yeah, just make sure I just do some logging to log. I can just put let me just do um, saved after.id. Cool. All right, let me make sure that I am doing okay. All right. And then, good hygienes, catch any errors. And yeah, get that from you. And then, cool. And then, what is it? Error saving. After.id. Cool. And then console.log. And I'm just going to log out the error. Console.error. Yep. Cool. So that looks good. So I think so. Yeah, let's make sure I did what I was supposed to do. So if it's these two things, basically I am setting the object ID to the after.id, which is cool. And then essentially I am saving this object, the after object. Yeah, should be all good from there.
The Algolia stuff looks good.
Okay. Cool, cool, cool. All right. So cooking with gas. All right. So now let's handle this wonderful delete case. So essentially, if we get the D record, yeah, let's basically do essentially the same thing. So let's see, console. Basically, I'm going to log out if the operation is D, like get the before, because I want to know what it looked like beforehand, and to find that record. Did somebody ask a question?
So someone did ask a question, but it's kind of drilling a little bit more into that whole
Yeah.
read event as a CDC event.
Yeah,
I mean,
I
we
would
can
have
talk.
to.
Mhm.
Yeah, I'll have to look at like I think it's because one of the connection mechanisms that we use behind the scenes is Debezium, and I know that's one of the things that they send over the wire. So again, it was just like one of those things for like just being thorough to make sure that we account for all the cases
Yeah.
so that we can get that down.
Yeah, again, keep in mind this is kind of a contrived example. I would say, that probably if we were doing like a real world example, maybe you'd throw reads on the floor because there wasn't an actual
Exactly.
mutation to the record. You'd probably also be doing a little bit more massaging of the data record as you push it out to the index. So this is really just kind of
Absolutely.
showing the basics of the operations.
Absolutely.
Yeah.
Absolutely. And the other thing too is I got to do everything I need to do to make sure that the demo guys will be happy. So I just wanted to make sure that that these things were working. All right, cool. So now I want to call an index delete object instead of save object. I don't know for .id. Cool. And then I'll say dot then promises, promises, promises. All right. And we'll do deleted, and then we'll just say before that ID. Cool, cool, cool. And then promise dot resolve, and then before. All right. All right. And then what I want to do is catch that again, and pass in the error. Console.log ID, and then we'll do a console.error, and then of error, and we should be all good. Yep, no errors, no any of that. And so I think the last thing that happens here is just that I just need to export my modules. Not that. Equals, and then this will just say update index. Cool. All right, so just walk through this again. Just make sure we did everything. We got our dependencies. I definitely don't need that. I don't know where the hell that came from. We don't. We got our dependencies. We created the client, ran the client, set the client index, and then now we're updating the index of records. We did the complete. I mean the these, and then now we got the write actions, and then now we got the delete actions. All right, cool. So now to your point, is like the dev loop, right? And so now comes the fun job of getting rid of all of this this stuff, right? So the first thing we'll do is just bring in our update index function that we have, and I'll just require dot slash Algolia.
So the demo code here, you could basically use the skeleton for just about any data app you're going to build at this point. This looks like
Yeah,
it has kind of all the
basically.
pieces.
Yeah, basically, pretty much. And so I'm gonna get rid of that. So the interesting thing here is that one of the cool things is that you can have private and public functions, right? And so the difference between this and Maroxa land is that this function right here, where you see anonymized, this is going to get pulled out at reflection and compile time, right? And then this one is just a function that is getting referenced by this, but you won't see this in the DAG that we build, right? Like only thing you'll see is anonymized or whatever it is that we're going to call it, which for right now, it's basically going to be called send to Algolia. So for me, I can get rid of some of this stuff right now. But to your point, if all I wanted to do was go from source to destination and anonymize some fields inside of a record, I can just basically replace any of that right now, like replace any of that information. And so that's one of the things that we're doing is just like trying to help people to understand, like, you can really get up and going pretty fast. I would probably say like, most of the cases that we have are around, just moving data from one place to the next. But yeah, you can definitely do a lot of the processing and stuff in between. All right. And so let me go ahead and knock that part out. Let's get rid of, yeah, we're actually going to use some of that. But I can get rid of a lot of this boilerplate. Let's get rid of this one. Let's get rid of this. And the cool part is like with this one, we're actually not sending it to a destination, so we don't need any of this. Really, that run loop is about 3 lines of code and and the function itself. So basically, what I want to do is I want to call this one send to Algolia, and it's going to take an argument of records. And so what I want to do here though is do a console.dir for records, so that way we can see what's coming across the wire when we actually run the app. And I'm going to set a depth to null. Cool. All right, and then I'm getting each one of the records, and essentially I can do the same thing here. I just want to show you all what the records look like. And I'll just change this records to record. And then all I need to do is just call the function now. Let me get rid of this. This is extraneous. All I need to do now is just call the update index method and just pass in the record at this point. And then, I don't need to unwrap any records. So essentially what unwrap does is that when you get a change data capture record, it's buried in the payload. I don't need to unwrap that because I actually want all of the payload itself. And you can actually see this in the fixtures that we have. So this is what it looks like, the actual record looks like for change data capture. And then here's what it looks like for just raw JSON. Like we're not getting any of that like before and after information. We're just getting the payload. So one of the cool things that we do though is that we embed the schema with every record. So inside of the Maroxa data plane, we have a schema registry. And so every single time like a record comes through, we make a check to see, hey, did anything change? And if it was a safe change, like, somebody, renamed something, then like we basically just pass that on. The event goes through. But, for unsafe migrations, there's a little bit more machinery that goes in behind the scenes to show something. I think we got a question there. Any future plans? Yes. Yes. Java is coming soon. Coming soon.
Yeah, so the question was, any future plans to support JVM languages, Java, Scala, Kotlin, or even GraalVM native images? And the answer is Java's coming soon. That's the answer I think folks like to hear.
Yeah. The next 3 languages we got up are Java, C Sharp, and Ruby. So
Nice.
they'll be coming soon for you all. So stay tuned. All right, so back to it. First thing that we need to do, I think we got everything going, but we just need to, our source is going to be our PG Postgres database that has logical replication. And then all we need is the orders records there. And we need, just change this. Yeah, I mean, I don't really have to change that, but I can say this is going to be this dot send to Algolia. And I need to pass in a few things here. which will be, and I'll just copy this down because I don't feel like writing this stuff right now. It's all these environment variables and these underscores. These things that gets on my nerves. But again, this is where we are grabbing the information. So yeah, this is the app. So now that we are done with the application, let me just make sure I got this. So we got the Algolia stuff. We have the records and all of that. Okay, cool. So one of the cool things is now I can actually test this. Let's see. Oh, it worked. Cool. Now, one of the fun things is what I found out during our testing, and I'll show you, right? Like it says it saved our records. And so by me putting in all of the console.logs, you can kind of see what those records look like in the schema. One of the fun things that I found out during my testing is that if I go through here, because we're not actually sending it to a local destination, these records actually show up in Algolia, the index here.
Yep.
So it works, right? Like, so like now I know it works, all right? So let me go ahead and just clear this out so you all don't think I'm BSing. And then let's go ahead and deploy this. And notice the one thing that I didn't say happened. You didn't hear me talk about having to run a Docker compose and like all this other stuff, right? Like it just literally runs in a buffer, a local buffer on your machine. So go ahead, Chuck.
So I noticed you were passing in the Algolia, the app ID and the API key. Is that because all of that sort of magic around the environment is within that sort of a main event loop in app.js? And so you've got to kind of push that out to the helper function?
Yeah, basically.
Okay, cool. So the helper function itself wouldn't have access to the magic. You kind of got to pass it through. That's good
Yeah,
to know.
basically, exactly.
Okay.
Because it doesn't get reflected out, right? Like
Got it.
it's just one of those things that yeah, it's a dependency, but like it's not part of the actual DAG itself. So
Okay.
let me good hygiene. Let me add everything, and then just go ahead and commit. And one of the cool things is that also too we can do branch deploys here as well if you wanted to. That's one of the things. But yeah, let me go ahead and just do a Maroxa apps deploy. Oh, demo guys.
So, and then just to kind of clarify what's going on here. So when you ran it locally, it was running against that fixture file.
Yep.
And so it's just pulling in the data, going through its typical loop. Now you're actually pushing it up to, is it the turbine framework? Is that what we call it?
Yeah, it's like we just call it the Maroxa
Maroxa
platform.
frame? Okay, Maroxa platform.
Yep, Maroxa platform. And then basically what it's doing now is like it's wiring all these things together. And I'll show you what it looks like in the dashboard and whatnot. But
Okay.
essentially what we're doing is now we are creating a here we go.
All right.
Demo guys were benevolent, I hope. So basically what ends up happening is come on, baby. Cool. All right. So what essentially ends up happening when I click in on this, right? Like you start to see that here's the input, here's the function, and here's what the output is, right? Like it's pretty ugly right now because I'm just using the default values, but this is the main thing. And so what ends up happening is like we wire all of this stuff in a DAG, like Kafka. We use that behind the scenes to handle all of the event streaming and all of that, as well as I'll show you what it looks like. So if I do a Maroxa connectors ls, you'll see that this one is we're using Debezium, the Postgres source here, and then we are outputting that into the function, which I can do. Show you that, all right? Like we're outputting that into the function. This is the input stream. The output stream here is the input stream of the function, and then that function is calling the send to Algolia function inside of our code. And so what I can do here is a Maroxa functions logs function -0 to 1 247. And you'll see we've gotten the initial records, right? Like that were already in the database. And so now when I go over to Algolia, All right, we got all of that. And so basically now what I need to do is let's go insert another record. And so let me bring back up my trusty Table Plus, which is the SQL client, and let's just add another ID in here and just run that. Insert into. This is 95. There we go. Index is there. Let's do 99 or run that, and I command you. Yep, there we go. Oh, it worked. Demo gods, thank you. Mic drop, all of that.
Well done. Well
We're
done.
good to go.
That's fantastic.
We need a
So
Tiger Wood fist pump. Yeah, there we go. All right. So now, anytime that there's a update to your Postgres database, your Algolia index will be updated as well. So this will be running behind the scenes, and everything will be all good. So just imagine if this was, your inventory or whatever it is. You have a separate inventory app. You don't necessarily need to do anything to the app itself. You just hook into the operational database, and then we keep all of this stuff in sync for you. So that's the magic, man.
very cool. Very cool. So I trying to kind of wrap my head around kind of the concept here. So, typically the event loop sort of becomes your replacement for your pipeline, right? You've got sources and destinations you're sort of defining
Exactly.
in there. And
Exactly.
then this Algolia helper is almost like a sidecar, right? You can kind of plug it in and say, hey, while we're moving data around, or even if we're not moving data around, um, call out to this every time there's a CRUD operation or a change, and update the index as well.
Yep.
Very cool. Very cool.
Yeah.
I think it's interesting that oh, and by the way, so if we're getting close to the end of the demo part, I'll remind you again, if you do have any questions, feel free to ask them in the Q&A section, and we can hit those. But I think it's interesting that you bring up Ruby as the next language, because one of the things that sort of this felt like to me was a little bit like active record, right? Where
Yep.
you kind of have this nice abstraction for your data, baked right into the code, but with this sort of addition of this event loop and the triggers, which is kind of interesting.
Yeah. I mean, the other cool part about it is like, um, a lot of people are doing these like ETL jobs, the T part with all this heavy machinery, right? So whether that's Airflow, whether it's Dagster Prefect, whether that's Spark and all of that, and it takes you out of your workflow, right? Which is like, for me, it was just one IDE, one screen. Like I could have done all this stuff in VS Code or whatnot, but I think that's really the biggest issue is that, especially in this data world, is that there's so many moving parts, right? And it's like, do I go to which UI do I go to try to troubleshoot? And it's like, yeah, I can just check this in to Git, have some folks code review it, and call it a day at that point. I can write tests against it if I want to. So all my friends are probably gonna troll me like, oh, where are the tests, right? Like, yeah, I didn't
Mhm.
write them because I only got 45 minutes so y'all can kiss my derriere. But yeah, you can just write regular tests, right? I don't need to set up another infrastructure component to understand what the output of a function is going to be,
Mhm.
and so that's really the benefit of just code, right?
Mhm.
Like, I mean, this is pretty easy. Like, you can get a boot camp grad to do this because if you really think about it, all I'm doing is just thinking about, yo, where's my data coming from? Where's it going? And then what format does it need to be when it gets there?
Mhm.
Um, the tooling complicates all of that, but like this is something that is I think it's pretty straightforward.
Yeah, yeah. And so, and the abstractions of the connections to the different, databases, Mongo, I saw you have Postgres, all of those. Those can all be managed centrally within the dashboard. I assume like you could
Yeah,
even theoretically have like, your database, you know, priests or whatever, build those out for you. So the developer doesn't
absolutely,
even need to know that stuff. And then
absolutely.
it's all abstracted away. So you can go ahead and kind of connect each of these. Now the Algolia stuff, it sounds like the challenge there is there's not really a source for it. Be interesting to see if that could actually be like a a first party source, but being able to sort of plug it in on as a sidecar like this, it's
Yeah.
not a lot of code, which is nice. The
Yeah,
clients.
well, funny enough, behind the scenes, we have an open source project called Conduit,
Mhm.
and we actually have an Algolia destination connector.
Oh,
But I
cool.
would imagine that we can also use. I mean, it's just a HTTP API, right? Like we can
Mhm.
just pull it from there and have it as a source. I don't know what people would use the source for
Mhm.
from Algolia, but it's entirely able to be developed. So
Yeah, we're
uh,
definitely more of a destination than a source, unless
yeah,
you're in the
yeah.
front end.
Yeah, exactly. So yeah, I mean this is yeah, we have a pre-built-in pre-baked source that we built as well. So it's open source. You can go check it out, conduit.io, or if you go on GitHub and search conduit, conduit.io is the org name. So yeah,
Oh, that's
we're
cool. Algolia has a code exchange, um, where we sort of have open source projects that support Algolia integration. So it might be, maybe we can work with you and we'll get it up in our code exchange too. That'd be pretty fun.
that sounds like it would be a good plan.
Hmm.
Yeah, this is the conduit project, and then we have a connector SDK and all that type of stuff.
Oh,
So
nice.
yeah.
Okay, that's pretty fun.
Yep.
Um, Again, if you have any questions, feel free to put them across. Although pretty smooth, pretty smooth demo there. Very impressive.
And it's been a while, so I'm like, yo, I'm not. I'm like, might have to go make a sacrifice for the demo guys later or something, right? But like, I think yeah, it's pretty straightforward and it really simple and shows the power of what just code can do.
Mm-hmm. Now, I guess question for you. So, obviously what you're doing right now is you're pushing sort of the raw records straight from Postgres, over to the index. Now, one thing that we talk about a lot is an index isn't a database, right? Like the whole point is speed when you're
Yep.
talking about an Algolia index. And so we recommend like shaving off as much of the data, uh, reducing down to the minimum amount that you need for a good search and discovery experience, making
Yep.
sure that the data is normalized appropriately. I would imagine that all of that sort of massaging ETLE stuff would happen within that helper itself. Are there any sort of best practices that you have for sort of doing those types of things, or is it really just like any other place you'd be writing JavaScript code to massage a JSON?
Yeah, I mean, essentially what you would do is like you can have one main function and a bunch of helper functions, and then you just basically treat it like functional programming, right?
Mm,
So, if you notice the original example had like an ability to hash a record or something like that, right?
mhm.
Like we would have a hash record function in here, right, and then call that for each thing.
Oh,
So
cool.
that's really like the public function, which is what we're exporting, is the just think of it as like the main, all right? And then you can have a bunch of helper functions underneath to essentially replicate your DAG steps, right? Like your orchestration steps after that. And so I think that's something like really that's what our best practice is for right now.
Got it. Got it. So there's an opportunity to sort of componentize and then build out sort of a library of best practices that anyone in the organization
Absolutely.
could then kind of include into whatever they're building. So you could just make sure that like,
Absolutely. Yeah, and then we're working on some things behind the scenes to make discovery of those functions and functionality a little bit easier. And I think that that's something that reusable functions and reusable components is a big thing. But I mean, again, it's just code, right? Like
mhm,
this is just JavaScript. So however you want to compose, your JavaScript files is perfectly fine with us. Like we do have some standards around like what you call the event loop, right?
mhm,
Uh, but outside of that, right? Like you can, just as I brought in this update index, function, right? Like you can have a whole bunch of them that you have in the library, right? Like you can be the like Algolia data library. You bring that in and it has a whole bunch of functions that you can use access through destructuring, right? Like that's something that you can do. I think one of the cool things, you mentioned it earlier before, is this whole thing of what we're trying to enable is not necessarily what they call data mesh, but really centralized resource, decentralized consumption. All
mhm.
right, so like you said, I can go into the catalog here and basically like everybody can build my resources and like all that type of stuff. Uh, Satish. So the question Satish had, if rate of changes in records is very high, higher than Algolia indexing rate, would it overload any of the two systems? The answer to that is no, because we use Kafka as a like a governor or limiter behind the scenes. So essentially, what ends up happening is that we pull in data from your Postgres, and then essentially it gets stored into Kafka as an intermediate. And then what we end up doing is like basically adhering to Algolia's rate limiting things behind the scenes as we're pushing records to the index. So it wouldn't overload it because we take very good care of making sure that upstream and downstream dependencies aren't overwhelmed by this stuff.
Cool. Right on. Well, we only have a few minutes left. If folks are interested in digging into more into Maroxa, what would be their next step? What would be their best way to get started quickly?
Meroxa.com. Check it out. And you can check us out at github.com/Maroxa. We got a bunch of repos out there yeah, we are. Let me just go ahead and show you. We got a bunch of repos to show you how we do what we do in various languages. And so yeah, just check us out. Meroxa.com, github.com/Maroxa. That's really where to go. So sign up. Is basically we have a generous free tier. I think you get some number of million events that you can pass through. You get unlimited compute. So yeah, we are. This is pretty cool product. And if you've enjoyed Heroku for many years, is how easy it was to build a web app. You'll get that same love and feel from the data outside. That's as much of a commercial I'll give y'all.
That's fine. I think you get a sentence. That's good.
Yeah.
So while we're out here promoting, I'm going to talk about one more
Stop
thing
streaming.
here, which is for those that don't know, Algolia is going to be hosting our first developer conference. It's going to be happening September 14th and 15th. It's going to be a virtual conference with watch parties in the Silicon Valley and in Paris. We'll be sending out more details over the next few weeks. But if you want to keep track, you can go to algolia.com/devcon and you can go ahead and register now. It's free registration. And hopefully we'll see some of you there. So that's my little pitch for today. I want to thank you, DeVaris, for taking some time to show us Maroxa and sort of how to integrate with Algolia. I love this concept. I love how code forward you are. Anything that abstracts away being able to handle database connections is a win as far as I'm concerned. So I really appreciate you showing this off today.
Yeah, thank you again for having me and giving me the opportunity to showcase what the combined power of our platforms can do, right? And I think that that's something that's super cool. I hope actually all of this is open source anyway. So if you go to our thing and search for the GitHub repo and search for the JavaScript examples, we have this in there. So if you're so inclined to just want to copy paste, it all works. It's all in there. But yeah, just thank you again, man. I'm really excited to see what people can go build.
Absolutely. I'll see you around. Take care.